Okay, so we can see there OE, it's going from the center of the circle to a point on the circumference, so that one is radius. Then FG is a similar thing, but it's going from one point on the circumference to another point on the circumference, and it's going through the center, right? So do we all agree that FG is a diameter? All right, next one, CD. This one is a chord, okay, because it's going from one point on the circumference to another point on the circumference, but it's not passing through the center. Okay, so we call that a chord. Guys, if this line went past the edges of the circle, past the circumference, what would we call it then? A secant. Secant, it doesn't matter how you say that. All right, a secant, so if it's going past. Okay, and then the last one, HI, this one here, this one is a tangent, right? It's only touching the circle at one point. Okay, let's look at the next one. I'll do this one with you guys just to save some time. So now they are asking us to, again, complete the following sentences, but now we're talking about arcs and segments. All right, so the curve BDC. So BDC is this section here. Now, guys, BDC is a section of the circumference, so we call that an arc. But is this the minor or the major arc? Minor arc. Okay, so just be specific there. Minor arc, because it is the smaller one. And then BEC is going to be the major arc. Oh, I see it's a different font on your page and on my page. Interesting. All right, next one. The area bounded by BC, which is a chord, and BDC. Now, guys, this kind of area is called a segment, right? But now we need to say, is it the minor segment or the major segment? The minor segment, because it is the smaller one of the two. So for the first one, we're going to write minor segment. And then the area bounded by BC, again the same chord, and BEC, that is now the major segment. All right, now guys, subtending, we need to talk about this. The whole concept of angles being subtended is very important in this section. Okay, I almost want to say it's the most important thing. So at the beginning, it might take a little bit of time to get used to the whole concept, but it's actually not that bad, all right? So what I want us to do, actually maybe you shouldn't do it, but I'm going to, although we're talking about CB and all of these. All right, so take a pencil or a colored pen or a highlighter or something and just highlight CB, because that is the chord that we are talking about in all three of these. Sorry, that line is a bit skew, but I can't fix it now. Now, guys, the term subtending is almost the same as forming, but it's a little bit different. We only use this term in circle geometry. In no other type of geometry will this term come up. Now, what is happening, guys, is if we're looking at CB, if you put your finger on C and you put your finger on B, right? You should have a line going from C, which is the one end point of the chord, and then a line going from B, which is the other end point of the chord, right? So you have a chord, and sometimes it can also be an arc, right? It doesn't have to be a chord. So we either could be talking about arc CFB or chord CB. We have the same two end points, okay? Whether we're looking at that arc or at this chord. So you need to identify the end points. And then from those two end points, you're going to have lines going from those end points. Where those two lines meet, where they intersect, they are going to form an angle between them, right? And that angle, we say, is subtended by that chord. So I'm looking at the first one. CB subtends angle what? At the circumference in the major segment. Do we agree that this is the major segment, guys? At the circumference would be at E, right? So I'm just going to highlight this quickly. You don't have to. But just so that you can see, we have a line going from endpoint C and from endpoint B. Those two lines are meeting up. They are intersecting at point E. And then we say that this angle is basically being formed by those two lines, right? But the proper term is subtended. So we say that the chord subtends that angle at the circumference. Yes, Catherine?
Ma'am, are we allowed to use the symbol that's on our worksheet in like giving reasons and stuff?
What for in your reasons? Yes, you can.
The word circumference isn't in our page.
Oh, a circle and a little CE. Yes, you are. Well, so kind of in our test we accept it, but it's not on the CAPS document. So, yeah, I would rather say circumf, so circumference like that. I would rather abbreviate it like that. Okay, just to be safe. Okay, so what are we saying here? CB subtends angle. Let's not just write E, okay? Let's do the full angle for this just to practice. Can we say CEB or BEC? Either way. All right, let's just write the full name there of that angle. Okay, I'm just going to erase this because I want to show you now the next one. But does that make sense, guys? You have a line going from each end point of the chord, and where those two lines intersect, they form an angle. Okay, that is what subtending means. Next one, CB subtends angle what? At the circumference in the minor segment. So now the minor segment is this one here at the bottom. So what angle is that? At F, hey. So angle CFB. Okay, and then we're going to say CB subtends angle what at the circle center O. So now they're saying the center of the circle is O, so that will be angle COB, right? Because again, we have a line going from each of the two endpoints, and they intersect at point O. So angle COB. Okay, any questions on that? I think the next question is also asking about subtending, yes? Oh, wait. Yes. Okay. Oh, I see the printing is also different. Oh, I wonder where I found this note. It's on here. It's from last year. Okay. So this one is on your page. It's the last picture. We'll talk about the middle one just now. Or is the middle one the one we just looked at? Yes. Okay. So the paging is just different. Okay. The last picture there, guys. I would like you to try and do that one on your own. It's a bit more difficult. So I'm going to give you 3 minutes. They're now saying they're kind of swapping it around in the first question. They're saying angle CBF. So let me just quickly show you which angle they're talking about there. Angle CBF is this angle here. Right? In the first question, they're asking that angle is subtended by which chord, basically. So you almost have to work backwards from the angle, from the two lines forming that angle, to see which chord it's going to, or they are both going to. All right, and then just answer the rest of those questions. See if you can on your own. I'll give you a few minutes. All right, what do we think for that first one, guys? What's the answer to the first one? Angle CBF is subtended by chord CF. All right, if you follow the lines forming that angle, they go back to chord CF. Okay, so that's the first one. Chord CE subtends angles. Now, guys, here the chord subtends two angles, right? So if we're looking at CE, do we all agree with CDE? Right, that one there. But then also, guys, if we follow those two lines, we're going up to CBE. Okay, so two different angles. Now, guys, we are going to learn theorems about that, but I'll spoil it for you so long. If a chord subtends two angles at the circumference, then those two angles will actually be equal to each other. All right, so that's going to be one of the theorems that we're going to use going forward, and we're going to have a reason for that. Okay, but we'll still get to that. Okay, show you there. Then chord CB subtends angle. So now CB is over here. Subtends angle CFB in the major segment, sorry. So that is the major segment, right? So CFB. Guys, if they had asked in the minor segment, what would our answer be? CEB. Okay, yes.
Then what if you said CDB?
Yes, you could have said CDB as well. Yes, correct. Yeah, CDB. That's 100% correct. Let's all add that actually, guys. Let's just add there and CDB, because there were actually two answers to that one. Okay, relax. All right, angle CFD. Let's quickly see where's that angle CFD. Is this whole angle here, hey? Is subtended by chord CD. Again, you follow the two lines forming that angle all the way back to a chord. All right, so CD is the answer to that one. I haven't written in the answer here because I want us to quickly find all of them. It's quite easy to miss one or two of them here. So we're looking at BD. Now, guys, notice that they're saying here minor arc BD, not chord BD, but it's the same concept. So now we are going to look at this arc. All right, I don't know. Yeah, I don't want it to correct to a straight line now. All right, so we're looking at that arc. But guys, if you looked at the chord, you're going to get the same answers. Okay, so don't panic now if you're like, oh, I looked at the chord and not the arc. It's fine. Again, you're going to look at the end point of the one, or the one end point of the chord and the other end point of the chord. It's the same 2 points, right? If you were looking at the sorry, I said the wrong thing now again. You're going to look at the one endpoint of the arc and the other endpoint of the arc. All right, B and D. But if you had looked at the chord, you would have the same 2 points. So you'll get the same answers. All right, so guys, let's take a look here. Do we notice this little angle here at the bottom? Angle F, CF, or BFD. All right, so that's one. Then we have BCD. BCD, yes. Right? Then we also have BED. Do we agree? That one up there. Is that it? I think so. Did anyone get any more? We have that one, and then we have that one, and then we have that one. Let's quickly check. Yeah. That's all of them. So the answer is 3. Now guys, from what I said earlier, when we are actually working, like doing calculations with this work, those 3 angles would all be equal to each other. Alright, so if they maybe gave you the size of that angle at E, then you could say, okay, but that angle is the same size. Alright, and then you're going to have a reason, which I won't spoil that as well. But yeah, that's what we're heading towards. Yes? Mm-hmm.
Could you say the COE?
They said at the circumference. So O is at the center. Yeah. Yeah, there's also nothing going to O. So guys, I didn't say this, but for subtending, I mean you could say, because which one are we looking at now? CE. Are you talking about this angle here?
Yeah, because in my worksheet it only says chord CE subtending angles at and it doesn't say in circumference.
Oh, I see. Okay. Fair enough. All right. Now, guys, for this work, the theorems that we're going to learn, they only work for, or they only apply to, I should rather say, angles at the circumference and angle at the center. All right. So an angle like this one here, I absolutely agree. Yes, it is being subtended by CE, but we're not going to be able to work with it going forward. Okay, which you didn't know, obviously. But is it labeled on your page, this point? No. All right. So you can't actually name this angle. Okay, so then we're not going to look at that one. But I do agree, it is formed by CE. All right, any other questions, guys?